What's up, right? I said, what's up?
This is a mock-up of a hydronic system for a typical building that has heating and cooling and uses water to provide the heat and cooling to the building, to each of the rooms. The way we designed this is example classrooms are each of these spaces here at the top, and at the bottom it shows an example of a gym. The only difference being that the gym shows the air blowing into the space from the top, overhead vents. The classroom shows something where the air blows in more or less at ground level, where it would be blowing through a unit vent through the wall, in the outside wall of the building, which you see in a lot of classrooms. Water circulated through these coils. This one's easier to see, so I'll point at the gym one. But there's a fan here that blows air through the coil. The coil just looks like a radiator in a car, has water circulating through it. If there's hot water in it, as the air blows over, it blows warm air into the space. If there's cold water in it, chilled water, it will blow cold air into the space.
So essentially one of these fans will be in each of the areas of the school that
Exactly. Each room has
the heat and the air.
Has a unit with fans. In a big unit, like in a gym, it would be referred to as an air handling unit. In a classroom, it's usually called a unit ventilator, which is a package ventilator on the outside.
I'm glad you said that, because I was wondering what the correct names for these were. Maybe just saying fan.
Well, yes, and that's fine. Now, this is just a mock-up. Normally, these units are also capable of bringing in a certain amount of outdoor air, so there's fresh air ventilation, and mixing that with a certain amount.
An air exchanger.
Right, and a certain amount of air will come out of the space and just be recirculated in an actual unit. So to make the water hot or cold, we used this chiller unit, which is actually for an aquarium. And we use this little electric heater, which is also for aquarium use.
Thing is just
that'll
heat it all up.
Yeah, and then there's a pump here that just pumps the water around through the system.
Will there be a comparable pump in the school?
Yeah, in fact, there's a set of pumps for the school. So the school would have several pumps.
Each go into a different part of the school, or
actually
just
for
redundancy?
For redundancy. So one pump and then a backup pump. So if one fails, there's always one to back it up, so the school doesn't lose conditioned space as it operates. One other point, that, as is typical, not in every building, but in a lot, the hot water and cold water share the same pipes. So we can either be cooling, air conditioning, as most people call it, or we can be in heating mode. But the building has to do one or the other. It's not going to do both simultaneously, because it's using the same pipes.
Okay. So
we call that a two-pipe system.
Mm-hmm.
One pipe sending the water out, one pipe bringing it back. So the name is two-pipe.
And that, it goes back to, I remember one of you guys saying that, or as of whatever date, April 1, the heat goes off, or whatever, March 1, the heat, it gets shut off, and then we can switch over the system, or give it a few days to, do whatever maintenance.
Exactly.
When
and that's a decision that the building operators need to make, depending on the conditions and the weather.
Sure.
And that's typical for this style of building design. There are other hydronic systems. If you get out a book of mechanical engineering, they have different ways of doing it, but this is typical for this kind of building. So, looking at the equipment, I'll start with the heater first. It's simpler. This heater, this is an electric heater for an aquarium. In the building actually has a boiler which burns natural gas to make heat.
Which a lot of us will have in our, students will understand,
Yes.
or might know, or could ask their parents, do we have a boiler, or do we have a furnace?
Right.
Electric or gas. Well, I guess the furnace could be gas too.
Yeah, it could be. Yeah. Yeah,
Yeah,
so,
that's
so,
what
you know,
I
this
asked
would
them that.
represent where our gas boiler is. And
I
so
don't-
the
so
boiler
I asked them
is
that,
more
and that's just
complicated
what they told me to
than
do,
this
to
little
look this up.
electric
So I'll
heater,
call
but
them
it
again.
shows us
Figure
how
out
it
what's going on.
operates.
I'm not sure.
The chiller,
I know.
this
'cause they
cooling
even
unit makes
connected
the
me to
water
my,
cold.
like, the department there that handles our
It
thing, our
operates
insurance, and they
really
told me to go
by
on this
the same
website
principle as the
and
chiller for
look
the
up
building
look up the
operates.
area for-
There's
and
a
Don said-
compressor in here
and
that
Don
pumps
said they're
refrigerant
covered.
around.
So that's what I'm
There's a section
confused about.
of the chiller that the water flows through that will make it cold,
Okay.
called the evaporator. There's another part of the chiller called the condenser where the heat is rejected, and there's fans in here that blow the
Blow it away from the
blow the
building.
heat away from the unit.
Do you have any other
And it's
PFC
very
that are
similar to
there
what
that
this
comes better?
this building actually has.
Okay. So basically, each of those fittings on top is one is just a water in, or hot
Right.
water in and cold water out.
Exactly. So one thing
Okay.
folks need to do when they operate this is they
All right,
need to
thank you.
decide
All right.
if they're going to run cooling or heating. In this building, in the actual school, the valves would be all operated automatically. There's a whole control system, electrically actuated valves, and the system will switch the valves and heat or cool. It can even be controlled to automatically do it depending what temperature it is outside. If it's hot out, go to cooling. If it's if it's cold out, switch to heating automatically.
So there's smart technology
Right,
in there, basically.
Right. Or it can be done by manual commands through the control system. But either way, it's all automated. For this, the valves are all operated manually, so we need to turn them. When we are operating, we need to decide which mode we're in. We don't want to run heat and cool at the same time. It's not going to work well, and they're not going to be great for the chiller or the heater to have hot or cold water running through the wrong thing. So we want to isolate it, and those valves are here to open or close. Simple thing on the valves: if the valve top is perpendicular to the pipe, it is closed. If it's in line with the pipe, it'll let water flow through it.
Maybe we could get a simple valve that isn't connected to something to show students
Yeah, that
how
to pass around.
inside how it blocks the flow
Yeah,
when they're turned off.
Because you can hold it up and look through it and turn it this way and see the light through
Yeah,
it.
I mean,
and
it's
vice
something
versa.
they will see other places in,
Yeah.
in their environment, in their
Yeah.
community.
Yeah, and these are very simple. It's called a ball valve. In other words, this really looks like a little ball inside with a hole through it, so it's very simple to see how it works. There's other types of valves, but these are very simple valves. Looking at the other valves, so the heating or cooling is going to flow through this system, go to each room, through the piping to the room, go into the coil, come back out of the coil for each room and the gym. What we can do with these valves is we can decide if the water goes through here or not. So this valve is a three-way valve, and this can be turned to either have the water coming into this unit go through the coil, or it can be diverted the other way, and in that case the water will bypass and skip this coil and just continue on around the loop.
So in that case, the gym doesn't get heat
Doesn't
or
get
air
heat or
conditioning.
cool. Right. This is very similar in operation to what the actual building has, except that in the actual building, these valves are controlled by electronic digital controllers that modulate these valves, so they don't just send heat or no heat to the room, or cool or no cool. They modulate, so it'll send a portion of the flow through this coil. As the room gets closer to set point, it'll start to throttle back. If the room needs more heat, for example, it'll send more flow through the coil. But in the actual building, this is a modulating, digitally controlled device. Each room has a temperature sensor on the wall and a controller in the unit that tells this valve what to do. So again, we're doing this manually so we can interact with it ourselves, but your actual classroom will have that all automated.
Very cool. Very cool.
Okay. A few other things. So I talked about the fan blowing into these units. just like a room or a classroom, if we blow air in, the air has to go somewhere. In this case, these little devices, these little dampers, actually mimic what we call barometric damper. In other words, if there's a certain amount of pressure in the room, the damper will open. So the more air blows in, the more the damper opens. It's simply a little flapper with a weight on it in this example. In an actual room, it's a little more sophisticated, but there is a unit that also is bringing air out, circulating air out of the room. There's a way to relieve air depending on the building design. So, you can never put air in without it having somewhere to escape.
Are you losing some of the heat or the air conditioning when that happens?
You can, yes.
Okay.
That's one of the trade-offs, but one of the things that are in some units, I need to check this building's design prints to know, some do use a form of heat recovery so that the heat in that exhaust air is captured and sent back in. So it minimizes that loss.
Interesting. Okay.
When we get the final control as-built, we can look and see how did they approach this building. I haven't seen them yet. But yeah, great question, and they can recover that as well. Each of these rooms has a little temperature sensor on it. So you can see when you're heating or cooling the room, you can see what's going on. And it also shows the relative humidity in the room. Right now it's very dry because it's, 20 outside, and yeah,
71
so it's
inside.
incredibly dry outside. And as you play with this, you'll see as you drive the temperature down, you'll see the relative humidity tend to come up, and vice versa. So when you make it warm, you'll tend to see the relative humidity fall. So we'll see that effect as well. If you're operating this in the summer, you might be able to get it cold enough to hit dew point. If you do, you'll start to see condensation on your coils and water dripping. So you want to be a little careful about that. It's not going to hurt anything, but it'll make this mock-up a little messy if you have water dripping on it. But it is something that happens in a real unit. A real unit has a condensate pan under it. The condensation off those coils, as it takes the humidity out of the air, and as the coils reach dew point, that water drips off of it, goes into a pan, goes
Like
into
our refrigerator.
goes into a drain, and the drain takes it away. So all units in the real building have condensate pans that take the condensate water away in the summer when you're running air conditioning there.
Like the dripping air window air
right.
conditioner units.
Right, exactly, like a dripping window unit, which a lot of people are familiar with. This does not have condensate pans, so if you are operating it and start to see condensate, you might want to back it off a little bit, or get out a sponge or towel and
just
mop
keep
up
it.
after yourself.
I don't think they'll run in that long that it'll get to that point.
But you might see them get a little wet, and that's actually a neat thing if they do.
It's a whole other set of
Right.
scientific principles to
Yeah.
explore.
So
Great.
depending on the age group, it may or may not be,